Any questions so far? Let me take some question.
Yeah, did you see my email? Because I think that the grade book was messed up because I saw that all the quizzes are from 2022 and all the assignments. And then you changed 2023.
Email. I don't know. Let
Okay.
me see. Let me see. Okay. Can you repeat again? Your question is like,
Well, because if you look in the my grade section on Blackboard, at least for us, and you look at like the week one discussion board, it says due January 16th of 2022, and like the quiz for this past week says due January 16th of 2022.
yeah, don't worry about the due date. Okay, the
Okay.
due date sometimes the system doesn't update, so don't worry about it. Yeah,
Okay.
and pretty much those homework, if you work on it before the end of the semester, I'll grade them. Okay,
Okay.
so don't worry about it. About it.
All right. Thank you.
Yeah, but that's a good question. Actually, the system sometimes doesn't update everything. Okay. Any other question?
Jeffrey, are you talking because you're muted?
Hmm?
Oh, sorry.
Yeah.
Thanks, Matt. Yeah, so did you just say that if we do homework late, that you'll still count it?
Still counted, yes.
Okay.
But if you are late,
All credit?
no, if you are more than 2 weeks late, may have some deduction, but I would say at least 90%.
Okay, thanks.
Yeah. You are allowed to be late, but not too late. But anything submitted before the last week, Sunday of the last week, we will grade that anyway. Because some students do need to have flexible schedule, right? Okay, it's noontime. Actually, again, this one is more for discussion. So if you have any question, you can interrupt at any time, okay? You can interrupt at any time. So last week, we are on the introduction. And this week, we are on memory model and data type, okay? So, but I'm not going to repeat the whole thing, okay? To repeat the whole thing, I think there are 194 slices. It takes a long time. So I would still suggest you to go to the course material week 2 and watch the video carefully, okay? Watch the video carefully. This one actually recorded for a long time. It's actually longer, maybe 2-3 hours, and you can pause, you can forward, you can actually be more flexible, okay? And actually, it's a lot of information in there, okay? So my purpose right here for the discussion is to give you the overall idea of what this chapter is, okay? And then take your question about homework or something else, okay? That's the purpose of this weekly meeting. So let's get started. Every language has its data type and the type system, okay? Some are strong type, some are weak type, okay? And before you know about one language, you need to know about its memory model and data types, okay? These are something, any language you get started, you need to know about these. Okay, so this chapter is dedicated to this data type system, strong type, weak type. These are different feature of the memories, okay? So data type, when you do AI, you start to collect the data, right? And you actually process the data. Let me show you some of the slices that I use in the high school course. Let me show you some of the slices that I use in high school course. Okay, so high school has AP Comp Sci principle, AP Computer Science principle. Okay, and this one is really important that you know about why data is important. So let me see. Nowadays we talk about data science. So let me actually bring up the slides. Okay, so this one, high school AP concept principle. So this chart. So no matter what purpose you have, we actually, one of the important things is that we are in a data science world, right? So data is very important. So you have the real world. Okay, real world, you may have 3 pitch. Okay. You may have a half slice of the watermelon, right? Whatever. These are real world entity, right? But when you represent the data in the computer science, we try to collect the raw data. So the raw data, when we try to collect the data from the real world, we do sampling. We do sampling. So for example, you have a thermometer. You try to read the reading of how many degrees C currently is, okay, or how many degree Fahrenheit it is. So there's a reading. There's some quantization error as well. So, but there's a collection process to read your data from raw data to from the real world physical quantity to the raw data. Okay. After that, the data being processed to integer to floating point number to string to Boolean value, right? These actually are the main data type in Python, right? And Python have numbers, text, and Boolean. These are 3 categories, and number can be divided into floating point and integer. So these are the data type in Python, right? But if you are in C++, there are tons of different type of the data type, right? You have integer 8-bit, integer 16-bit, integer 32-bit, integer 64-bit. You have signed integer, you have unsigned integer, you have actually double, you have long double, whatever, tons of different data type. So every language, the data type is different. And they are designed in that way to suit certain computing purpose. But anyway, before you learn some language or pick up some language, one very important thing is like you need to know about the data type is really suitable to your goal of the computing. Then you pick the language. Okay. This course we pick Python just because Python has many features that can represent data science and AI and machine learning. Okay, and also the language translation, and also object-oriented programming, functional programming. So Python is a full-blown language. So that's why we want to spend more time on it. But real programmers, sometimes you need to choose the language, the best language you can use. So basically, you need to know about the data type, what data type is supported, and so it will basically support your computation. So maybe if you go down to the low level, maybe C, C++, or Rust language, that would be performing the best performance, right? Okay, anyway, you have to do each data type. And each data type, each language, they have the data model, they have memory model in your machine, right? Then your language, you need to actually tabulate your data. And then you clean out some data. So basically, you may have some survey made by the street side data collector, right? And those data, some people just fill in wrong name or wrong ID or wrong age. So you need to clean out the data. So first step is actually clean up the data. And then you do exploratory data analysis. And then build machine learning model and put those machine learning model for historical purpose. So you can do learning and then build a learning model and later for better making decision, right? So this is the whole thing for the data science, life of the data science, okay? I would like to emphasize the life cycle. So basically, when we collect the data, there are 2 types of data. One type is quantitative, one type is qualitative. Okay. So quantitative means that you use integer or you use a floating point number. Quantitative means good. Okay. High quality. Okay. And then edible. Okay. Some word describing the data. Okay. So usually quantitative data is more like string, okay, more like string. But sometimes the qualitative data also carry. I mean, nowadays you can use AI to read the so-called semantical analysis to understand. Okay, for example, some people do semantical analysis on stock market. Okay, so you will know that currently the stock market, the whole moon is actually passive or very optimistic. Okay, so they are qualitative research, quantitative research. These are both important research in data science. Okay, and your language need to support this data science process. Okay, and maybe it actually depends on different language. You do have different data type. Okay, so here I'm not trying to go through the every languages, every data type, but just tell you when you study the data type, you need to understand why you need to choose this language and why this language is best for you. For example, Python is simple. Python's data type is actually very concise, right? But the memory management is poor because you may use a lot of long integers. If you want to optimize for the memory purpose, then C will be a better choice, right? So that's something you need to keep in mind. Second, type system. So type system, you do have the different language do have the strong type, weak type, okay, static type and dynamic type. Okay, these are four corners of the type. Okay, here I just want to give you the very easy definition. Okay, strong type means that whenever you actually use the language, you have an integer, you declare it, and the type is actually being strongly described, right? These are strong type. Weak type language like variable, okay, JavaScript, right? And you never know what language, what type it is. So later you need to use the type inference to figure out what data type it is. It is a string or it is actually it is a string or it is a Boolean value. And JavaScript is available. You A assign a true, and later A assigned with 1 is actually legal. Okay, it actually is legal. So this type of language, we call it weak type. Basically, there is no such, not strongly enforcing the type. That is weak type, okay? And then strong type language is that when you declare it, you have to follow it. It's integer. An integer is an integer. A short is short. A byte is byte. It's unsigned integer is unsigned integer. Okay, so far okay.
Yeah, so far okay.
So far okay. And then static type and dynamic type is like static type is like your type decided at the compile time. That's a static type. Dynamic type is like when you run it at the runtime, you determine it. So something like JavaScript, as I say, runtime you have A equals 1, you have A equals true. So you have to use a function called type of A, and then you figure out each type, right? Python is the same thing. Python also is a more of the dynamic type language. Okay, so these are some features. When you know about the language, these are the types. Okay, so type system is to support the computation of this different type determination. You want to decide which type it is, but the type system is used to do that. Okay. Okay, so this one is type system. Every language has its own type system. So right here, your data type will have meaning of the type, polymorphism, also even type equivalence, type compatibility, type invariance. These are different language features. We call it type system. It used to determine your type or compatibility or your compiler, whether it will pass or fail. So these are the contained in this type system. Okay. Okay. Then next one, C++ type. So TW+ type is going to be the most complicated type. You have the integer type, floating point type. You have the Boolean type actually is integer type. Okay, CW+1 is 0 is false, and non-zero is actually true. Okay, so there's Boolean type as well, but bool type actually is also fundamentally actually is integer type. And they are string, they are pointer, they are pointer, they are reference, okay, they are the second level pointer, okay, all kind of different pointers, okay, in CW+. So they are derived data field, array, pointer reference, and the user defined structure. Okay, these are the data type in CW+. It's very probably the most complicated data type for all of the language. Okay, and beyond the data type, you also need to know about the memory model. Okay, so memory model, CW+ memory model is the most lower level memory model because the C language or CW+ language, it directly mapping to the your CPU's instruction section, data section, stack section. Okay, those operation system turn CW+ directly operating them. Okay, so when you learn CW+ language, you need to know about these basic memory models. Okay, any question? Okay, so this is CW+ memory model. But when you learn Java's memory model is different from CW+. You learn Python's memory model is different from CW+. So when you learn the language, whether it's a pointer or it is a reference, or is a array to a pointer, okay, or array of reference, it really depends on the language, okay? And the memory have different access model. This one in the assembly, okay? And the memory has different hierarchy, okay? You have your DRAM, right? DRAM, main memory, and you have cache, and you have cache 1, cache 2, level 2 cache, even level 3 cache. You have register inside the CPU. This we call it memory hierarchy, okay? And they are different speed and different buffering purpose. And there is a cache hit, cache miss ratio problem. Okay. Okay, here we are not discussing the hardware, but you need to know about the memory different level. Python language is a memory model. Okay. Python language is on top of CW+. Okay, so basically below this line is a C language. Okay, and Python language has a Python virtual machine. So you're operating on Python virtual machine. Okay, you're operating on Python virtual machine. So Python virtual machine has Python object allocator, Python heap, Python raw memory allocator, and these operating on the Python virtual machine. And Python virtual machine is a CW+ program, an executable program, and that is your Python.exe. Your Python.exe is your Python virtual machine, and this Python.exe manage the memories. Okay, and every day you are talking to the Python virtual machine, and everything in Python are objects. Python do not have the primitive data type. It's everything is an object. So that's something you need to know. Python has heap, okay, and Python has these different things. So Python, when we go to the very late chapters, when we go to the very late chapter, let me show you the chapter 15, okay? Lecture 15, I'm sorry. Lecture 15. Let's jump to the lecture 15. Lecture 15 or 16, okay? Let's see, scheme parser, lecture 15. You talk about Python virtual machine, okay? So when we go to the chapter, lecture 15, we talk about this, the nature of the Python virtual machine. And your Python program actually talking to Python virtual machine. So Python being interpreted to Python virtual machine. And Python virtual machine manage your CPU. Okay, is that okay? So Python is an interpreted language to Python virtual machine, and Python virtual machine run for you. And here they show you how the Python virtual machine would work. But this one is in lecture 15. Okay, we are not trying to teach you Python virtual machine right now. Okay, just that you know Python code stack. Okay, Python virtual machine Bible. Okay, if you are interested in Python virtual machine, is in lecture 15. Okay, and right now we are not talking about it. We are talking about Python memory model. So to know about the type, you need to know about Python's memory model. And Python memory model is on top a Python virtual machine, and Python virtual machine is written in C, C++. And anything you know about Python is object-oriented, pure object-oriented. Everything is object. So Python's data type, pretty much data type, they are objects. They are object, but they do have function associated with it then. So you may have the string, you may have integer, you may have float, you may have boolean, and you may have the function that can operate, okay? And beyond that, you also have the sequence, list tuple string, okay? This tuple string. So Python's primary data type are here, up to here, okay? These are primary data type. Boolean, string, float, integer, complex. These are keyboard type, okay? And then compound data type, you have set, string, list, tuple, dictionary, okay? And Python's tuple using parentheses, okay? Set using curly braces, okay? String use double quote, single quote, or triple quote. Everything quoted is string. List use bracket. Okay, dictionary use curly brace, key, column, value. Okay, there's another type of dictionary. So when you talk about a Python type, you just need to remember the different symbol that use for this compound type. Okay, parentheses is for tuple, bracket for list, double quote for string, curly brace for set, curly brace key, column, value for dictionary. Okay, I usually teach students like this, then they can remember all of the Python compound type. Okay, any questions so far? Any questions so far? So type, usually you have primary type, compound type, okay? For C++ language, the same. They have more weird type, okay? But similar, they are primary type and common type. But in fact, Python's whatever type, they are all object oriented, okay? They are all objects. And then use Python and C++ and JavaScript. The data type is almost one-to-one mapping. So you have the JSON format data actually is the glue between JavaScript and Python. So usually some program use a Python for backend, okay, and JavaScript for the front-end computing. But the data can be converted from one language to the other in a very efficient way. So Python's data string in JSON is also string. JSON is JavaScript object notation, okay? And then Python's integer is JSON's integer. Python's float is JSON's real number. Python's bool value, Boolean value is the JSON's bool value, okay? Python's list is JSON's array, okay? Here, actually, Python's sequence has more type. And so actually you set your tuple, your list, your everything sequential data JSON is just one array type. Okay, and the Python's dictionary is actually the object in the JSON. But Python also have the user-defined object. It's actually totally different from this JSON's object. Okay. Okay, so these are actually comparison between the JSON object type and the Python data type. Okay, and if you use a NumPy for Python, there are more data type being introduced because Python's basic data type are too few. NumPy have more type. Okay, NumPy have more type. Okay, so this portion is the basic data type that Python has. Okay, and the next one is expression and value. Expression and value. Every language has some expression. Okay, an expression will give you some value. Expression is part of a statement. But the key is that you will return you some value. Okay, that's called expression. Okay, and expression, I don't go into the detail. You need to study it. Okay, so this portion is quite simple: plus, minus, multiply, exponent. Okay, my goal is not to teach you these basic things. It's just go over to tell you what I cover in each chapter. Okay, so this portion, I mean, just you have to study by yourself. Okay. Naming system. Okay, so next one, expression is for the return value. The name system name is actually will have a bounding with a certain value. Okay, so in the name, okay, then name. So available, you say integer a equals 3, a associated with a certain memory location. This location may be F3P, F3A4. So the association of the name and the memory location, this we call it binding. Okay, this is the name. This is your memory location. Okay, so this is a form of binding. Name and the binding. Okay, so the binding is you have a husband and wife, and husband and wife is the binding. Okay, you go to church, and then the priest or the declare that you're husband wife, but maybe 2 days later you divorce, right? So the binding will be destroyed when you divorce. Is that okay? So any naming, any binding will be temporary. Will be temporary. Someday you are going to die. You are not going to be with your wife forever, right? So binding is temporary. So because of binding is temporary, you have to look at the reference environment. Reference environment. Your local are you in the loop? Are you in the loop level, or are you in the function level, or are you in a stack of different function? And also different level, we call it reference environment. So reference environment will include in all of the binding between the different variable and the memory. And because you may have local variable, you may have global variable, so the binding at a different time will be associated with different locations. So you say A, you may have different A, you may have a for loop, integer I equals 0, whatever, okay? And they may be A, and this A is associated with a local variable A, right? But you may have in other place, there may be another A. So that A and this A may be different. So that actually you have to refer to your reference environment. Okay? So binding is the association of your memory and the memory location. While where you are binding to who, that actually is the reference environment. Maybe you have a wife in America and you have another in Shanghai, right? I don't know, maybe. Is that okay? And that's actually based on the environment. Okay? So that's actually a name can be bound to a value. Okay. A name can be bound to a value at a single time, right? But in different reference environment, you may be binding to different data, and that's the name rebinding. Okay. Okay, so this is the idea of name and the scope and the binding and the reference environment. Okay, next one is the composite data type. As I said, they are different composite data type: records, unions, array, string, tuple, list, set, dictionary. Every language has different compound type. And compound type is the organization of data. So you can think about compound type as data structure, okay, as data structure. And whether you use it or not, it actually depends on your problem, okay, depend on your problem. And different language, the compound type is different, okay. And Python type is very easy. As I say, look at the quoting, okay, quoting, parenthesis, okay, bracket, curly brace, colon, comma. Okay, these are different. But if you know about this, your Python will be very simple. Okay, the compound type. Okay, we do have different string, and string have string creation, string indexing, string slicing, string operation, string method. Okay, here I'm not trying to teach you everything. Okay. One thing I would like to know, that you know, is there's an F string, there's an R string, there's a U string, and normal string. So when you have a U before it is a Unicode string. There's an R string is the raw string. Okay, F string is a formatted string. So they are different definition. You have to look into internet to find out what are the definition of this. Okay, so they are different, and also byte. UTF byte string. Okay, so string alone, Python support different type of string. So far, okay. And they are indexing. You need to figure out slicing. You need to figure out. Okay, we do not have that much time to cover everything, but you need to study. Okay. And these are the functions associated with the character and string. You need to know it. Okay, we do have the sample code you can download to run it. Okay, I wrote this. Okay, I wrote this. So this is since like in the course material. Here we do have an in-class demo code. You can download. Okay, you can download. They are called. You can download to look at different things. You have to run to understand. Okay. Okay, so these are different string type. If you have any question, you can interrupt me at any time, okay? I'm going very fast because there are more than 100 slices. And I try my best to just give you some overview, okay? So they are call, you can call. You can run, okay? So they are data type, okay? And indexing, okay? You have to look at it, okay? Substring, how to do substring slicing, okay? You have to study these, okay? So I don't go over these details. They are called, you can run, and you can figure it out, okay? Already document them. Okay, this portion, let's just go faster, okay? And the basic operations are here, okay? String methods, okay? These are usually when you learn a language, you know about string, you need to know about the strings indexing method, you need to know about its function, okay? Basically, something like that. Okay, and then string operation for Python, okay? And formatted string, next one is your formatted string, okay? Formatted string, Python take two system, okay? Python have the formatted string just like C++. Python also has its own formatted string, okay? So this formatted string, the regular C++ type of the formatted string is a little bit modified by the Python. So here, when we have this one, that is, okay, This means that this 0 is used to replace this percentage 3D. Okay, so this one, if you are in Java language, is actually system.out.println, printf, okay, printf, and then you do percentage 3D, okay, and then comma 0. So usually in Java, it actually is percentage 3D and then comma 0. Okay, and here you use a percentage sign. Percentage sign means this one to replace it here. Okay, and this is quite useful. So you do not need to remember the formatted string if you use this as standard C++ type of the formatted string. Okay, it's the same as Java as the C++ and as the Java. Okay, as Java. I'm sorry, as C language type. Okay, so this one you can go through it. Okay, I don't have time to demonstrate every single one. And tuple. Tuple, you need to know tuple is a list of data that cannot be changed. Cannot be changed. So it actually is immutable. Okay. Anybody know what immutable is? Anybody know what when we say some data is immutable, what does this mean? Let me see. Let me try. Okay. I
Can't be
then
changed. Can't be changed.
Cannot be changed. Yes, it cannot be changed. So your data, you cannot. You have a tuple. You have 3 and 4. Then you cannot change it. You say it's T. You cannot make it you cannot grow, or actually you cannot make it 3, 4, 5 by using insert. You cannot do insert. You cannot change anything. So the data is immutable. Okay. So by definition, tuple is a immutable list. It's somewhat similar to the array in Java. It's somewhat similar to the array in Java. Okay. So you have basic operation for the tuples. Okay. And usually what is tuple being used is like you are using it for X and Y 2-dimensional data, or SYG 3-dimensional points. Okay. And you use it for point. You do not want to create a classical point, and you use this tuple to as your data type. Okay. That's the use of tuple, but you cannot grow. You cannot. Okay. Here you do have a plus sign. You are connecting the two, but you will actually get a new tuple. Okay, this is a new tuple. This one's new. It has nothing to do with the previous one. It's just connecting them and create a new one. Okay. Okay, and you can use as multiply 4. So here, one thing is that you need to remember that tuple. If you are only one element, you need to put a comma. You need to put a comma. So only one element, one tuple. You need to do this. When you type, you need times 4. You will become 4 of the high string. Okay, these are tuple. So far, okay.
And you can use any data type in there?
Yes, you can do any data type in there. Yes, it's a collection of data. And you can check the membership, whether 3 is in there or not. Okay, so this one is your list, your tuple. Okay, so this is defined tuple and trying to use it. Okay, and there are examples. So here we do have a swap function using tuple, and we do have GCD, GCF using tuple to calculate. Okay, you can look at the sample form. Next one is list. List, you can think about it as array. And you can also think about it is similar to array list, but list in Python is very, very powerful. So basically, it's not array. It's not array. It's more powerful than array. It's more similar to array list in Java, but it's actually even more powerful than array list. Because list you can mix data type together, but array list in Java you cannot, okay? You cannot mix the data type together. So list just a concept. We call it abstract data type, okay? You can put anything okay, and even another sublist into a list. Okay, anything you can put in there. So this is a sequential data type. It's more powerful than array, more powerful than array list in Java. Okay, and there's a conversion from string to list and list to string. Okay, so you can use join to join 3 entity list to a string. You can use split to split the string back to a list. Okay, so there's way you can convert the data type.
I have a
Okay.
question about
Yes,
tuple.
yeah, go ahead.
When do you usually want to use a tuple? I mean, is it
Tuple
like,
usually in the calculation of mass, you want to use it for point. When
and the
you
values will never change?
let me change, yeah. But you can use it for calculation. Usually when you use for mathematical calculation.
Okay, thanks.
And when you use the list that you can always remember you have object-oriented programming. So object-oriented programming means that you have more function associated with some data type. Then the computation speed would drop. Then your computation speed will drop, right? You get more function means that your object is bigger. Then your speed will drop. So sometimes you would rather to use tuple instead of list because what? Because tuple calculation is lighter and the speed will be faster. But don't worry about it, okay? Don't worry about it. You have a tuple equals 1, 2. You convert it to list. You just say list t, then you become a list 1, right? And your list 1, you say tuple, you convert to another t2. Is that okay? So it's always convertible. So you don't need to worry about, hey, I declare my 2 points in tuple, so I cannot change my size. No, you can convert it to list and then you change the size and then convert it back to tuple. Does that make sense? In a way, list is like a vehicle or it's like a mechanism that you can do more operation for the tuple and then you convert it back to the tuple. Okay, so when you need a higher speed computation, tuple is faster because their function are fewer, the data structure size is smaller. Okay, is that okay? Is that okay? So your list can grow, can become bigger. You have to insert, you have the pop, you have the push pop, you have insert, you have append. Your list can grow. Array will not. Array in our knowledge is not in no, okay? But your Python language do not have array. Python language does not have array. So when you want to use a fixed size array, you use NumPy. Okay, you use NumPy. You mainly go Python. Okay, you use NumPy. Is that okay? So get the NumPy, you basically get array, you get matrix, you get any of the numerical calculation. But in this is more flexible. This you actually can change the size of the data structure, but array you cannot. Array is fixed size. So here sometimes you need to have NumPy to convert between list and array. Okay. Any question? I'm talking about more advanced topic, okay? Because I'm assuming the basic Python people, all of you know some of it, okay? If you do have question, let me know, okay? And Python's list can be heterogeneous. That means that a single list can hold arbitrary data type, okay? Array, no. Array, you have to be the same type, okay? Okay, anyway, there are some examples, okay, for this. Okay, and you can convert between NumPy array and a list, okay, and also NumPy metric and array, okay, it's something important. And also they are comprehensive list, okay. Comprehensive list actually is like you can create, okay, a new list, okay. Word zero means that here I'm trying to get the first character for the every word in A. Okay. First character of the every word in A. I'm going to put it to a new list called array, called first, and I join them together. So this one will be I, A, G, S, F, W, H, S. Okay. This one in homework, you will exercise it. Okay. You will have some exercise on this one. So here you need to understand what's the comprehensive list, okay? It's the way to create a list, okay? For word in A means that for every word in A, you get this word's first character to form a new list. Then you join all of the first data together to S and then print it, okay? Okay, so that's the comprehensive list. The next one is a set, okay? This was a set. Set is used for membership, whether some data is in there or not, okay? And set is non-recurring compared to list, okay? List you have 1, 2, 3, that's okay. But set you can only have 1, 2, 3. Whether it's in or out, you cannot have recurrent data, okay? So this is a set. Okay, so by set you have AND operation or operation. Okay, this is just a part of the basic set theory. Okay, and here you have the length of a set, checking whether an element is a set or not. Is this a subset or is it a superset? It's an union, intersection, difference. Okay, or copy a set. Okay, and you can use this simple notation for it. Okay. Okay, this is a set. Okay, dictionary. Dictionary is object in JSON. Okay, in JSON in JavaScript. Dictionary is kind of very interesting. Okay. Okay, this one actually is very useful in competitive programming. Okay, so dictionary in Java, we call it map. In Python, we call it dictionary. In JavaScript, we call it object. Okay, it's the different way to look at things. Okay, so let's start with the JavaScript. Okay, so for example, we have a student, and this student can have a name. So the name that's assumed is actually called Eric. Okay, and then age. Okay, age in another property. That's assumed is like 20 years old. I'm sorry, this is actually using comma, okay. So they are property of a certain object. That's actually for JavaScript. And in Python, it becomes dictionary. It is named dictionary. Dictionary means that you have a key and value pair. Okay, and in Java, it's called map. So basically, dictionary is used to keep track of the key value pair. Okay. JavaScript call it object because you do have a CSS and you do have a background color, and that maybe is white, right? So this is a pair of the key value, but it actually is in the object format, and the object being stored in the JavaScript DOM, document object model, right? So we call object, but in Python it's called dictionary. Okay, it's called dictionary. Any questions so far? It's very powerful. Okay, it's very powerful. For this dictionary, you can view it as an object. If you do not like to set up the class, dictionary almost can do everything that class can do. Okay. Okay, this portion I don't want to waste time. Just go through the different. Okay, so here your dictionary. Dictionary. You can extract the key value. You can extract the value. So let's see. So here you may have the key, okay, value pair, okay. So here let's assume that we do have the name, Eric, okay, age, 20, okay, GPA, 3.4, okay. So basically when you say keys, you will take this one out as a list. Okay, when you say values, you will take this one out as a list. Okay. And if you say there's a, I'm sorry, this one is actually values. This yellow one is values. You can use the keys function to extract your keys out, all the key out. You can actually extract it by using values to take it out, okay? You can also extract them using items. So items will extract tuples of name and Eric. That's one tuple. And then age 20. That's the second tuple, but I'll put them into a list. Okay. So dictionary can be extracted to list using the keys function, value function, items function. And later you can also use the zip function to zip them back. There's a zip function, you can also zip them back. So what I want to say is that dictionary can also be converted to your list tuple, and your list tuple can also be converted back to dictionary. There are some way you can do it. Okay, same thing here. You have to look at my code. My code will teach you how to do it. Okay, is that okay? So far, okay. Hello, so far, okay. Let me see how much
Yep, so
you
far
have.
okay.
So we actually finished the basic Python portion. The session A is NumPy, is optional. It's not standard Python, okay? You need to install the numerical package in order to get this NumPy. It's no longer standard Python. The next section, the NumPy portion, okay? So we pretty much finished everything there. So here we start to talk about NumPy data type. These are additional, and they are array, they are matrix, they are indexing, slicing, 2D operation, transpose of the matrix, and all kind of metric operations. Okay, this you need it if you try to do AI. Okay, but after this is optional. Okay, because we are not AI course. Okay. Okay, NumPy is a numerical Python. Okay. Some people say NumPy, some people say NumPy. Okay, whatever. I take everyone. So I usually call it NumPy. Okay. And NumPy has arithmetic operation, statistics operation, bitwise operation, all kind of operation you need. Okay. So NumPy is pretty powerful. I would say if you just know generic Python, it's not enough for data science. It is not enough for data science. NumPy is something like you must know. Okay, you must know because there are a lot of things: array, linear algebra, metric operation. These are related to AI, data science, all there. Okay, so NumPy actually is used to create NumPy array. As I say, NumPy array is array. NumPy array is not list. List in Python is a list. So list can grow and shrink. NumPy array, no. NumPy array is a fixed size data. Okay. So NumPy array. NumPy array, when you have one data, we call it scalar. Two data, 1D, we call it vector. 2D, we call it metric. 3D or more, we call it tensor. Okay, tensor. So tensor, you might hear of it before. If you look at the Google Tensor processor, these are the newest AI computing devices, and AlphaGo use it to play Go game with human master. Right, it's a tensor processor, and you may install TensorFlow for AI processing. Okay, these are something you need to know. So tensor is a higher degree array, higher than third degree. We usually call it tensor, and in fact, tensor can also include first degree to second degree things. Okay, it's a generic name. So this you need to know. Okay, 1 dimension, 2 dimension, 3 dimension. They have different name. Multiple dimension still called tensor. Okay, and here we do have the 1D data's operation using array. Okay, and these are operation. I don't go into the detail. Okay, because it takes too long for me to finish. But we do give you this different code to look at. Okay. It takes some time. Okay, it's not 1 hour, probably 4 or 5 hours for you to finish it. Okay, but it actually will help you and how to create array. Okay, these are okay. I don't have time to go over every single statement. Okay, and array arithmetic, how you calculate the operation of 2 array, data plus 1, 2 arrays sum together. You actually add in each element. So this one is used for vector addition. Okay. Vector addition, vector subtraction, vector multiplication, vector division. Okay. It's a per element operation. And the parallel can be parallel operation. Okay. And then you can have the vector scalar multiplication. Okay. Conceptually, you need to understand this basic concept. And there are also index and slicing. Index and slicing in array is similar to your list. Okay. And this one, I just skip it. Okay. And then you can create 2D array as metric. Okay. 2D array as metric. Okay. Same thing. There are so much detail. Okay. You have to look at it. And you can do transpose and reshaping. Transpose means that your row become column become row. Okay. Transpose. Reshaping is the original data is 6 by 1. You can change it to 2 by 3 or 3 by 2. Okay, this is called reshaping. Any question? Okay. multiple dimension data. Okay. So here, I mean, this NumPy has many things. And you can also, there are also how to insert deletion of the row or column to a matrix. Okay. When you have two-dimensional array, how you can insert or delete a column to it. Okay. Add a row. Okay. Add a column. Okay. Delete a row. Delete a column. Okay. These are basic metric operations. Okay. And multiply a row. Okay. Okay. Those just quickly go over. We finish this week's topic. Okay. And you need to spend a lot of time to look at it, look at the code. My purpose of going through here is to give you an overall view and let you know what you are starting here, okay? As for the detailed code, I mean, it takes longer time. I can never finish it within 1 hour or even 3 hours. I think you need to spend maybe 5 hours to actually really understand everything if you are beginner, okay? Any question? But you know, our overall goal is like to help you to master Python language. When you try to find a job, you are well around. Okay, you are well trained in one language, so you are able to locate a job. Okay. Any question? Any question about today's overview or homework so far? No? Ryan, you are trying to say something or no? Okay, if no question, we are done here, okay? Thank you for joining us, okay? Bye-bye. See you next time.